Hello, Algebra 2 students. So today we're going to take a look at solving quadratic equations by graphing. So we're still going to graph the quadratic equations like we had done previously, but we're looking at the solutions, which are the x-intercepts of the graph. So as a quick review, the quadratic function looks like y equals ax squared plus bx plus c, or in place of y, you put f of x, that's function notation, equals x squared plus bx plus c. And in a quadratic equation, if you set it equal to 0 and solve, those are your solutions. But when you're graphing them, the solutions, like I previously said, are your x-intercepts. That's where the graph crosses the x-axis. So we're going to approach these today by graphing. So if it says, again, solve by graphing, so we're going to go through everything as we would have before. So my function is going to be f of x equals x squared minus 2x minus 8. So again, my a would be 1, my b would be negative 2, and my c would be negative 8. Okay, so since my a value is positive, it's 1, it's going to open up. My x of the symmetry, remember, is x equals negative b over 2a. So since b is already negative 2, I'm going to put a positive 2 over 2 times a. So 2 over 2 is 1. So again, the x of the symmetry is x equals 1. The vertex is going to be at 1 comma something. To find the something, we're going to plug 1 in for x. So we're going to have y equals 1 squared minus 2 times 1 minus 8. So 1 squared is 1. So 1 minus 2 minus 8. So again, left to right. 1 minus 2 is negative 1. Negative 1 minus 8 is negative 9. So the vertex is at 1, negative 9. And my y-intercept is 0 comma something. My something, remember, is the c value, the constant. So it's going to be 0 comma negative 8. So if I graph the points that I have, again, the vertex is 1, negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the vertex. The x, the symmetry, is again x equals 1. So there's my axis of symmetry. My y-intercept is 0, negative 8. So remember, my graph is symmetric over the axis of symmetry. So I also have this point of 2, negative 8. Now, I need 5 points, remember, always to find, to make your graph. So I need to pick another point to plug in for x. So let's go to the right. So let's pick 3 to plug in for x. So I'm going to have 3 squared minus 2 times 3 minus 8. So that's going to be 9 minus 6 minus 8. So left to right, 9 minus 6 is 3. 3 minus 8 is negative 5. So if I have the point 3, negative 5, 1, 2, 3, 4, 5. Oh, 1, 2, 3, 4. Should be not there. Should be there. And then I also have the point negative 1, negative 5. So there's my 5 points. So again, I'm going to try to be as accurate as possible, and I'm going to draw my graph. Okay, so I'm going to solve by graphing. So it looks like I have 2, again, x-intercepts. One is located here at, what is that, negative 2, and the other one is going to be located at 1, 2, 3, 4. So again, if I'm going to solve by graphing, my 2 answers are going to be x equals negative 2 or x equals 4. So again, those are my 2 solutions, negative 2 and 4. Okay, so if I do the next one here, so same kind of thing. Now notice the equation, the function equals 0, so I'm going to rewrite it as f of x equals negative x squared plus 4x minus 3. So my a value is negative 1, my b is 4, and my c value is negative 3. So since the a is negative, this one is going to open down. My axis symmetry, remember, is x equals negative b over 2a. So I'm going to have negative 4 over 2 times negative 1. That's going to be negative 4 over negative 2, which is positive 2. And my vertex is going to be 2 comma something. To find the something, I'm going to plug the 2 in for x. So I'm going to have negative and then 2 squared plus 4 times 2 minus 3. So it's going to be negative 4 plus 8 minus 3. So if I go left to right, negative 4 plus 8 is positive 4, and 4 minus 3 is 1. So I have a vertex at 2, 1, and my y-intercept is 0, the constant, and the constant is negative 3. So if I plot my points, 0, negative 3 is here. My vertex is 2, 1. My axis symmetry, remember, is at x equals 2. My graph is symmetric over the axis symmetry, so I also have this point here of 4, negative 3. So I always need 5 points for my graph. So let's plug in another point. Let's plug in 1 for x. So I'm going to have negative and then 1 squared plus 4 times 1 minus 3. So this is going to be negative 1 plus 4 minus 3. So this is going to give me a 0. So I have the point 1, 0. That means I'm also going to have the point 3, 0. So there's my 5 points. If I draw my graph here, again, the solutions are my x-intercepts. So it's going to be at 1 and at 3. So it's going to be x equals 1, or my other answer is 3. 2 possible solutions. Okay, and the last one. Notice my equation is not equal to 0, so that's the first thing I need to adjust. So I'm going to have x squared minus 6x plus 9 equals 0. So to write it as a function, I'm going to say f of x equals x squared minus 6x plus 9. So my a value is 1, my b is negative 6, and my c is 9. So this one is going to open up because my a value is positive. The axis symmetry, remember, is negative b over 2a. In this case, my b is negative, so I'm going to put 6 over 2 times a, which is 1. So that's going to be 6 over 2, which is 3. So that means my vertex is 3, something. To find the something, I'm going to plug in 3 to my function. So I'm going to have 3 squared minus 6 times 3 plus 9. That's going to be 9 minus 18 plus 9. So left to right, 9 minus 18 is negative 9. Negative 9 plus 9 is 0. So my vertex is at 3, 0. My y-intercept is 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, my axis symmetry is at x equals 3. So if I draw that in, again, my graph is symmetric. So I also have a point here at 6, 9. Again, I always need 5 points for my graph. So let's plug in, let's plug in a 2. So I'm going to have 2 squared minus 6 times 2 plus 9. That's going to be 4 minus 12 plus 9. So left to right, 4 minus 12 is negative 8. Negative 8 plus 9 is 1. So I'm going to have 2, 1, and I'm also going to have the point 4, 1. So again, notice I have my 4 points. If I draw in my graph, notice I have one x-intercept. That's where the vertex is, and that's going to be located at 3. Okay, so again, the focus for today is solving by graphing. So something to keep in mind here, if I look at my possible options here. So if the vertex is on the x-axis, you have one solution. So that could look something like this. That vertex is one solution. It has 2 solutions if it opens up and the vertex is below the x-axis, or it opens down and the vertex is above. So if I have something like this, I have 2 solutions, right here and right here. I have no real solutions or 2 imaginary solutions if it opens up and the vertex is above the x-axis like this. Notice it doesn't cross the x-axis at all. Or the other option is the vertex is below the x-axis and it opens down. Do you see again how it never crosses the x-axis? So therefore there's no real solutions, but we have talked about imaginary already this year. That would mean there's 2 imaginary solutions, and we could find them, but just not by graphing. So today's assignment, you are going to do lesson 9-2, the one we are, the worksheet. If you have any questions, please let me know.